Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.1, Problem 13. This is number 13 from Section 2.1. Solve the system of linear equations 2x plus 7y equals negative 8 and negative 2x plus 3y equals negative 12. So to start, we want to multiply one or both equations times some value so that one of the variables will have the same number in front but with opposite signs. Now in the case of number 13, I don't really have to multiply either equation times anything. I have a positive 2x in the top equation and a negative 2x in the bottom equation. So I already have the same number in front of one of the variables with an opposite sign. So step 1 really requires no work. I can move on to step 2, which is add the equations together in order to cancel one of the variables. So if I add them together, 2x and negative 2x, the x's cancel. 7y and 3y is 10y. And then on the right side of the equal signs, negative 8 and negative 12 combine to give me negative 20. So that's step 2. I added the equations together to cancel one of the variables. Step 3 is solve for the remaining variable. So if I divide out the 10 in front of the y, I'm going to get that y is negative 2. I have negative 20 divided by positive 10 is negative 2. Now the final step, step 4, is take the answer from step 3, plug it into either of the original equations, and solve for the remaining variable. And you should get the same answer either way. Because the top equation doesn't have as many negatives, I'll choose the top for that reason. Though you should get the same answer either way. So I'm going to take the top equation, which is 2x plus 7y equals negative 8. Take my answer from step 3, which is y equals negative 2, and put it into that equation. So 2x plus 7y becomes 7 times negative 2 equals negative 8. So now 2x plus 7 times negative 2, it's going to become minus 14 equals negative 8. Get the 2x by itself, so I'm going to do plus 14 on the left side of the equals and plus 14 on the right side of the equals. And I'll finish that over here. I'm going to have 2x equals the negative 14, positive 14 canceled. On the right side of the equals, I have negative 8. Positive 14 will be positive 6. Solve for x, I'm going to divide out the 2. 6 divided by 2 is positive 3. So the solution to this system of linear equations is x equals 3 and y equals negative 2. Or again, if you want to think of it as a graph, if you graph these, the point at which they would intersect would have an x-coordinate of 3 and a y-coordinate of negative 2. Again, those x and y values should make both equations true at the same time.